Good morning. We learn our chapter 15 probability. Example number 4. On one page of a telephone directory, there were 200 telephone numbers. How many telephone numbers? On one page, 200 telephone numbers. The frequency distribution of their unit place digit is given in table. Suppose our number is 2564038. Then what is our unit digit? Unit digit is 8. Then also any number. We write here without looking at the page. Dot on the page at the page and put pencil. The pencil is placed on one of these numbers. Pencil is placed on one of these numbers. What is the probability that the digit in its unit place is 6? Telephone directory. On one page, there are 200 telephone numbers. 200 telephone numbers. Total how many numbers? 200. In table we have given the frequency of their unit digit, of their unit place digit is given. The frequency of their unit digit place. Unit place digit. Without looking on at page, we place pencil on number. What is that number? The pencil is placed on one of these numbers. What is the probability that the digit in its unit place is 6? Here we write total number, total trial, total numbers. We write here total numbers is equals to, on a page is equals to 200. We find the digit in its unit place is 6. What is probability? The probability of the number that the digit in its unit place is 6 is equals to frequency of the number of frequency 6 upon total number. Frequencies number 6, unit place at 6. What is frequencies? How many times is 6 in on page? 14 times. Unit place is 6. Then it is unit place digit is 6. They are 14 times. Total number is equals to 200. We write here the pencil of place on one of these numbers. What is the probability that, here we write the probability that the digit in its unit place is 6 is equals to the probability that the digit in its unit place is 6 is equals to frequency of number 6. Therefore, given numbers, frequency of number 6 upon total numbers. Frequency of given 6. Suppose we have question that unit place is 9. Then we write frequency of 9 is equals to 20. Frequency of 5, its frequency is 10. Here frequency of number 6 is equals to 14 upon total number. How many total numbers? 200. Say 1 2s are 100 2s are equals to 0.07. 0.07. Again question. On one page of telephone directory, there were 200 telephone numbers. The frequency distribution of their unit place visit in given table. Without looking at the page, the pencil is placed on one of these numbers. What is probability that the digit in its place is 6? Then first we find frequency of place 6 is equal to 14 upon total number is equal to 200. Answer is 0.07. Okay? Understood this question? You don't write here this number. It is for your explanation. Example number 5. The record of weather station shows that out of the past 250 consecutive days. How many consecutive days? 250 consecutive days. Its weather forecast were correct 175 times. Report is given of 250 days. There are 175 times is correct. Then how many times it is incorrect? 250 minus 175 is equal to 50 times incorrect. What is the probability that on a given day it was correct? Correct number is 175 upon total number 250 and then simplify. What is probability that it was not correct on a given day? Not correct days are 250 minus 175. Total days minus correct days, then we get no correct days. Not correct days. Here our solution. Total days is equals to 250. How many days? 250 days. Weather forecast were correct. Correct. Weather forecast correct. Weather forecast where correct days is equals to how many times? 175. Not correct days is equals to not correct days is equals to 250 minus 175 575 times. I say 50 times, it is wrong. It is 75 times. Correct days 175 times. Not correct days 75 times. Here it is our information given in the question. We find number 1. What is the probability that on a given day it was correct? The probability that on a given day it was correct is equals to PA. PA is equals to 175 upon 250. Here the probability we write here. Is that on a was correct is equals to P. So PA is equals to correct days is equals to, we know your formula, don't otherwise you don't write formula. Suppose you write formula number of correct days upon total number of days. Here I write correct days is equals to 175 upon 250. 25 say 1 za, 25 10 za. You directly write 7 upon 10. I say 1 by 10 is equals to 0.71. Answer is 0.7. Number second, the probability that is that on a given day it was not correct is equals to, we say here any event PB. Probability that means P and event is P. PB. PB is equals to, not correct days is equals to, we find 200, 250 minus 175. It is not given. For we find that 250 days total days, 175 correct days. Therefore, 75 not correct days is equals to 75 upon 250. 25 3s are 25 10s are is equals to 0.3, which is our answer. Again this question, total number 250. Given correct days, correct 175 times whether report is correct. Whether report is not correct is equals to, we find here 250 minus 175, therefore 75 times. Now find the probability that on a given day it was correct days is equals to PA. Therefore PA, so PA is equals to 175 upon 250 and not correct days 75 upon 250. Then our answer are 0.7 and 0.3. Now example number 6. Example number 6. In textbook, you read this question. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. The table is given here. Distance in kilometer, frequency here, less than, tire covered less than 4000 kilometer, its frequency is 20. 4000 to 9000 kilometer, 210. 9001 to 14,325 and more than 14,000 is equal to 445. How many total 1000 pieces? How many pieces? Here total 1000 pieces in given question, and some of these 5, 5, 10, 1, 5, 2, 7, 8, 10 and 2, 6, 3, 9 and 2, 11. 210, 325, 445. Okay. Again 5, 5, 10. 2, 4 to 6, 6 to 8, 9, 10, 11, 20, 210, 325 and 445. Okay, its sound is 1000. If you buy a tire of this company, what is probability that it will need to be replaced before it has covered 4000 km? Before 4000 km, that means less than 4000. Before 4000, then 300,000, 3500, etc. Here before, therefore less than 4000 km, frequency 20 upon 1000. It will last more than 9000 km. Here up to 9000 km. From here more than 9000 km, 325 plus 445, 770. And it will need to be replaced after it has covered somewhere between 4000 km and 14,000 km. Between 4000, here less than 4000. Between 4000 and 14,000 km up to two columns, 4,000 to 14,000. Here this column is less than 4,000 and it is more than 14,000. Find probability of, what is probability then? Again this question, a tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. The table shows the result of 1000 cases. Distance in kilometer, less than 4000, 4000 to 9000, 9000 to 14,000, more than 14,000, 20 to 10, 325, 445. If you buy a tire of this company, what is probability there? And then 3 questions. Now we solve this question. Here we write what is probability that it will need to be replaced before it has covered 4000 km. Then we write probability of that it will need to be replaced before it has covered 4000. Otherwise, you write probability that tire will before it has covered 4000 km is equals to PA. PA is equals to before 4000. Before 4000 is equals to 20 upon 1000. Here we write probability of that, number 1. Probability of the tire will need to be replaced before it has covered 4,000 km is equals to PA. Therefore, PA is equals to before 4,000 less than 4,000 is equals to 20 upon 1000 is equals to 0.20. or 0.02. You write here 0.02. Number 7. It will last more than 9,000 kilometers. More than 9,000 kilometers. Probability of that, just number of tire covered more than 9,000 kilometers. First we find the number of more than 9,000 kilometers. Here up to 9,000. First column and second column. Less than 9,000. More than 9,000, it will equals to 325 plus 445 is equals to 770. Then probability of tire will last more than 9,000 will cover more than 9,000 kilometer is equals to PB. Then PB is equals to 770 upon 1000 is equals to 0.77. Number 3. It will need to be replaced. It will need to be replaced after it has covered somewhere between 4,000 kilometer and 14,000 kilometer. It will cover number of tire covered how many? Between 4,000 kilometer and 14,000 kilometer. Covered between 4,000 kilometer and 14,000 kilometer is equals to between 4,000, here less than 4,000, then column second and up to 14,000 and column third. Sum of these two columns 210 plus 325 is equals to 535. Probability of tire will cover between 4,000 kilometer and 14,000 kilometer is PC. What is event? It is event C. PC is equals to PC is equals to 535 upon 1000 is equals to 0.535. Question number, example number 6 again. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. The table shows given below. Here table is given. Distance in kilometer less than 4,000, 4,000 to 9,000, 9,000 to 14,000, more than 14,000. Frequency 20 to 10, 325, 445. If you buy a tire of this company, what is probability that it will need to be replaced before it has covered 4,000 km? Here total time, total kilometer is this 1000 cases in how many frequency? 20, 210, 325 and 445. Number 1, it will need to be replaced before it has covered 4,000 km. Less than 4,000, before that means less than 20 upon 1000 is equals to 0.02. Question number 2, it will last more than 9,000 km. Then more than 9,000, here 325, we calculate 9,000 to 14,000 and more than 40,000, 325 plus 445 is equals to 770. Then probability of this event is equals to 770 upon 1000, 0.77. Number 3, it will need to be replaced after it has covered somewhere between 4,000 km and 14,000 km. Between, here start 4,001, 4,000 to 14,000. 210 plus 325 is equals to 535. Its event is C. PC is equals to 0.535. Understood this question? Example number 6. Here example number 6. Now example number 7. So easy. A student's question is like this. The percentage of marks obtained by students in monthly unit test are given below. Marks obtained by students in unit test given below. First unit test, second, third, fourth and fifth. How many unit tests? 5 unit tests. Percentage of marks 69% in first test, second test 71, third 73, 68, 74. Based on this data, find the probability that student gets more than 70% marks in a unit test. Students gets more than 70% marks. We observe the table. Marks, percentage of marks more than 70% in second test, in third test and in fifth. How many tests did he get? He or she gets, student gets more than 70% in 3 tests. How many total test? Total test is equal to 1, 2, 3, 4, 5. Student gets more than 70% marks in 3 tests and total 5 tests. The probability of this get more than 70% marks is equal to 3 upon 5. Okay. We write here. Student gets 70%, more than 70% marks in test, second, third and fifth. Total number of tests is equal to 1, 2, 3, 4, 5. Total number of tests is equal to 5. And student gets more than 70% marks number of more than 70% marks in test is equal to 1, 2 and 3. Number of 70% more than student gets number of test students get more than 70% marks is equal to how many? 1, 2 and 3. Therefore, probability that the probability that student gets more than 70% marks equals to more than 70% marks is equals to 3 upon number of marks is equal to 3 and total 5. Probability is 3 upon 5, otherwise you write in 0.6. Both answer correct. Example 7. Here we have given test marks table in percentage. Find the probability that student gets more than 70% marks. Only one question. More than 70% marks. In how many tests? Student gets more than 70% marks in second test, third test and fifth test. In 3 tests. A student gets more than 70% marks. Total test, how many? 5. Then frequency of probability of this is equal to 3 upon 5 is equal to 0.6.